Hello and welcome to another video in the Cisco ACI bite-size series. These ACI bite-size videos are meant to be a small, easily consumable, digestible, tasty treat of technology, showing a specific element of the Cisco ACI configuration. In this video we're going to create a L3OUT dedicated to a particular tenant. So there's a few steps involved here. So we're going to confirm our root reflectors are configured. Obviously when we advertise a external route into the ACI fabric via whichever protocol, that is redistributed into multi-protocol BGP at the leaf and advertised up to the spine. Hence these spines need to be configured as root reflectors. But as we'll see, that's pretty straightforward to do. Then we're going to configure our VPC to the external router, in this case an Ospf external router. Then we're going to create our L3OUT, our routed outside, associate that bridge domain to that L3OUT, and then set our bridge domain subnet to advertise externally. And then we're going to do some confirmation that we've got connectivity in and out of the fabric. Okay, so this is the topology we've gradually been building up with these bite-sized videos. So we're going to be concentrating on the top left-hand corner here. So we have a Ospf external router configured with a VPC to our two leafs. And yes, Cisco do support a dynamic routing protocol over VPC with Cisco ACI. So from a policy perspective, this is what we're going to be configuring. So we have our two leafs. In this instance, our workloads and our L3OUT will actually be connected to the same leafs. Chances are in a production environment you would probably have a pair of leafs dedicated to external services. Whenever you've got an external entity coming in, or an external routed entity coming into a Cisco ACI leaf, they're termed as a border leaf. i.e. is the border of the network between your external routing environment and your ACI fabric. So we've got our web EPG down here, which we created in the Cisco UCS bite-size video. We've got our bridge domain, which we've just named VLAN 10 and associated a gateway address of 10.10.10.254 with, and that's within our private SDN lab VRF. In this instance we're going to actually be advertising and consuming that L3OUT purely within that tenant's VRF. In subsequent videos we will look at creating a shared L3OUT using the common tenant. So lots of reasons why you might need an L3OUT for a particular tenant. It might be that they've got a WAN link, or a link to a large legacy environment over a routed connection. Or in this case you might just have the internet. Everyone wants the internet, obviously, so that's probably a very common requirement. So you can see there the elements that we're going to work with in this video. So our EPG that we created earlier. So we're going to create our L3OUT and associate our bridge domain, our VLAN bridge domain, to that L3OUT, and then we're going to create a contract between our web EPG and our external internet EPG. The external internet EPG representing the networks outside of the ACI fabric in this case. Okay, so let's get on with the configuration. So as mentioned, the first thing we're going to do is just confirm that our root reflector is in place, because obviously all the routes that we'll be learning via Ospf and advertising into the fabric will be redistributed into multi-protocol BGP at the leafs, advertised out to the spines, and thus these spines need to be configured as root reflectors to ensure those routes are propagated to all other leaves. So we did this when we first set up the fabric, as you should too. But if you want to see where that is, we go into fabric, fabric policies, pod policies, see what policy group we're using, which is pod 1. So we can see there our resolved BGP root reflector policy is the default one. So we'll have a look at what the default one is. we can see that we have allocated a private AS number and indeed selected our two spines as root reflectors. So first things first, let's just check in on our external router. Let's have a look at our show ether channel summary. Okay, so we've got our ether channel facing the ACI fabric. So you can see there it's currently not receiving any LACP traffic, so that both the ports are in isolated mode. We've certainly got no OSPF neighbour adjacencies with the ACI fabric. Okay, so this is the default route we're going to be injecting into the fabric, as well as a Pacific route 1.1.1.1 representing the internet. VLAN 100 is the VLAN we're going to use for our SVI. So we're going to have a little broadcast domain on VLAN 100 that we'll use to establish our OSPF adjacencies. So we're going to have an SVI on our border router, which is .1, and then an SVI on our two leaf switches, .2 and .3 respectively. So we'll have two OSPF adjacencies formed across that virtual port channel. Okay, so it's important to remember that that's VLAN 100 because we will have to honour that encapsulation when we get to configuring the other end in the ACI fabric. So let's keep that router handy. We'll check on that little fella from time to time to see how he's coping. Okay, so first thing that we're going to do is actually just create the standard VPC to that external router. So again, we'll get fairly familiar with that process now. So we'll go to our access policies and again do it with the wizard. We've already got our switch policy containing both leaf 101 and leaf 102. So I'll just reuse that and create a new VPC. And this is port 148 from both leaf switches. Just double check, 148, 148. Again, we love that symmetry. Makes policies a lot more optimal. Okay, so again, we'll call this something a little more sensible. We'll call this external router. Okay, so it's a disable CDP. We always prefer LLDP to infrastructure devices, and we're going to configure LACP active to match the configuration of the layer 3 switch on the other side. Okay, I think that's all we need there. Now what's on the other end of this VPC? It's going to be an external routed device, so fairly an obvious selection there for an external layer 3. We're going to create a domain name, so we'll call this external router domain, and we're going to give it a VLAN range. Now this is the VLAN that needs to match the encapsulation on the external physical router, so that was 100. We can save that and save and submit. Now that should be enough to get our VPC up, so we can see it there associated with that VLAN 100. Let's check in on our router. That looks like some things are happening. Okay, let's show our ether channel summary. We're now 2Ps, which means we're receiving LACP traffic. Still nothing from the OSPF yet, but that's to be expected as we haven't configured the OSPF side of it. If you want to have a look at the OSPF side on this router, it's fairly basic. Show run section OSPF. Okay, so we just advertising a couple of networks, a default route we've configured as area 1. If you want to have a look at the SVI facing the ACI fabric, again pretty basic, just an IP address essentially. Okay, so let's go and configure up our Ospf side. So let's just cancel out of that wizard. I need to go into our tenant, into our networking. Again, a fairly obvious choice. It's external rooted networks. We're going to create a rooted outside, and we'll call this external router, and we'll make it Ospf. Okay, it's a regular area. Area 1 matches. Root control enforcement, so we're going to leave that unchecked, so which means we'll accept all routes by default. VRF, we want to add it into our SDN Lab VRF. As mentioned, this L3OUT is only for this particular tenant. In a subsequent video, we'll do a shared L3OUT via the common tenants. Okay, and I think that all looks okay. So let's add our nodes. So we've got this node profile. And we want to add our nodes in. So select node 1, which is node 101. We'll give it a router ID, which Ospf will use as its loopback. And we'll just give the router ID repeated 4 times. And the same for node 102. Okay, let's create our Ospf interface profiles. So again, this is where we'd change things like MTU if we needed to with one of these policies. But for our requirements, we can just leave them all as default. Okay, so this is where we'd configure our Ospf authentication if we were using any, which we are not in this case. The only thing I will need to change is this Ospf policy. We're using an SVI here. We'll call it broadcast. I'll select the network type as broadcast. We want to advertise the subnet, ignore the MTU. All the timers are OK. So we can go next. Okay, so we've got a choice here or a couple of choices. We've got a rooted interface option, an SVI option, or a rooted sub-interface option. Rooted interface would be a no switch port equivalent on the leaf switch ports if it was going to a rooted port. SVI, which what we'll do is just using a VLAN interface on the leaf switches to establish the adjacency. Or you could have a rooted sub-interface. For example, if this was uplinking to a switch which had multiple VRFs, you'd probably use the rooted sub-interface option. But we're going to use the SVI, and we're going to create these 2 SVIs here. We have our A side and our B side. So I'll add those in now. So we have our virtual port channel we created earlier. And that's it, external router. VLAN has to match, the encapsulation has to match, so it's VLAN 100. Trunk is fine. Our A side, which is our node 101, will be 100.0.0.2/24. And our B side will be .3. You have the option to provide a secondary IP address here, so you can have a HSRP type setup with a shared common address between the 2 nodes. But for our purposes, we'll just establish our adjacencies on these SVIs. Okay, so that's all okay. Okay, so that's a little summary there. We can go with that. And a little summary there. So okay, and our final little summary there. All looks okay, so we'll go next. So our external EPG networks. So this is this red box we're going to create now and allocate our external subnets to it. So in this case it's going to be internet with a all zeros range. It could just easily be an external customer range. Okay, so let's add that subnet in. We'll call this internet. So this will be our external EPG, which we'll need to provide a contract between. And we just need to advertise this the subnet, which will be 0.0.0.0/0. And again, we're only using this for our own VRF. We're not going to be sharing it between other tenants, so we can leave all that as standard. So okay for that, okay to that, and finish. Okay, so check in on our external router. Oh, looks like there's lots been going on. So I do a show IP Ospf neighbor. Okay, so we now have our two adjacencies to our two leaf switches. I do a show IP root Ospf, and I've got a couple of Ospf roots there, which are, you'll remember, are the loopback addresses of our leafs, which I should now be able to ping, which I can. But you'll notice I am not yet receiving our bridge domain prefix, our 10.10.10.10 subnet, which is again by design because I haven't told that bridge domain or the net to advertise externally. So what we need to do now is link our bridge domain, our VLAN 10 bridge domain in this case, to the L3OUT that we've just created, and specify that our subnet associated with that bridge domain should be advertised externally. So let's go and do that. So we need to go into our bridge domain, our VLAN 10. We have our L configuration. So we have here a box that's associated L3OUTs. So we need to add the L3OUT we've created to make that association. External router. And then we need to go into the subnet, which by default is set to private VRF. So we need to advertise that externally. So we'll submit that. And let's go and check on our external router again. IP root Ospf. So now we have a Ospf external type 2 route with our prefix of our web bridge domain. So does that now mean we can ping into our endpoints within that web EPG? 10.10.10.1. No, we can't. But again, that's by design. It's because we are now just missing the contracts between the two EPGs. So essentially this in here. So we shall go and rectify that. Okay, just before we do that, let's just do a few pings. So let's do a ping 1.1.1.1.1 -t. So this is from our endpoint within our web EPG. So that's certainly not pinging. So that'll be the object of this exercise to get that working, and vice versa, pinging this VM from our external router. Okay, so I mentioned the only thing we're lacking now is a contract. A nice little tip, I guess, if you ever think you have a contract issue, or you think you may have a contract problem, and there is a nice quick way you can actually disable all contracts within a VRF. So I'll show you how to do that. So the ping is failing currently, and we suspect it could be that we haven't a contract or a misconfigured contract. So we can go into our VRF, and we have this option here, Policy Control Enforcement Preference. By default it's enforce, as it should be, but we can unenforce it and submit. So that in essence bypasses all contracts and puts a global permit all in, which we can check. Our ping is now working, so we know it is a contract issue, or in this case the lack of a contract. Let's just rectify that, put that back, which should kill our connectivity. Okay, and let's configure it up the right way. So let's go into our external routed network and go and find our internet external EPG, which is there. So let's go into our contracts and let's assign a contract. Again, the contract we're going to use is the default common contract, which is a bidirectional contract, so it doesn't matter if it's a provider or consume, it'll work both ways. So I'm going to update that, and let's go to our web EPG and put the same contracts in for web contracts. Again, it doesn't matter if we're providing or consuming in this case, because it's a bidirectional contract. Common default. Okay, let's check in on our web. Okay, so that has got our connectivity back up and working. Okay, so again on our external router. So we have our bridge domain prefix. So let's now see if we can ping into the fabric and ping an endpoint.1. And we can. So we have bidirectional communication in and out of the fabric by a L3 routed domain. Okay, and there's a couple of checks we can do within the fabric, so it's always nice to be able to view it from both sides. So we can actually go into our leaf switch, we can have a look at our Ospf neighbours from the ACI point of view. I'm going to show IP Ospf neighbours VRF all. We should see a couple of neighbours there. Yep, so we see our external neighbour and our peer leaf switch as a neighbour. It's all fine. And then we should also see our route table. So we do a show IP route VRF all. We should be able to see all our different routes that we're learning for particular VRFs. And if we find our SDN lab VRF, we'll see we're receiving our default routes and our mock internet route. Okay, so that's a little recap what we've just done there. So in this video we've created an external L3OUT. We've configured a VPC from an external layer 3 switch. We've created our L3OUT. We've created our external EPG with the appropriate routes associated. We have associated our bridge domain with the L3OUT. And we've also created a contract between our web EPG and our external EPG to allow all traffic. And we've configured the subnets within our bridge domain to be advertised externally. And that was all working. So that concludes the video for this bite-sized ACI L3OUT demonstration. So in the meantime, take care and hope you can join me for the next one. Bye bye.